So in an earlier video, we looked at how you can take three atoms of helium and fuse them together to get carbon-12. We're now going to take a look at something called the CNO cycle, which is another part of this process of nucleosynthesis by which we create light elements inside of stars. So let's take a look at what happens to this carbon-12. Carbon-12, we'll write it here. It has an atomic number of 6. It can react with a hydrogen atom, so we'll just write it as H using the symbol for hydrogen, 1 proton and no neutrons, so an atomic weight of 1, and that can react to give us nitrogen 13. That's got an atomic number of 7, and then there's some gamma radiation that is released. And then that nitrogen 13 can react, or rather decay, into carbon-13, and then that will release a positron, an electron, a thing with the mass of an electron but a positive charge, and then a neutrino of some type, and then some energy. And then that carbon-13 that's produced by decay, it can react with another hydrogen atom somewhere in the center of this star, this hypothetical star, and then it will react to form nitrogen 13, again, plus some gamma radiation and plus some energy that will be output. Excuse me, not nitrogen 13, nitrogen 14, right? We add 13 and 1, that'll give us 14. And then we're going to take that nitrogen 14 that we've just created. That will react with another proton, another hydrogen atom in the core of a star, and that'll create oxygen 15. And then there will be some gamma radiation and some energy that will be released. And then that oxygen 15 will react, so excuse me, it will decay into nitrogen 15, then plus another positron and a neutrino of some type. And then finally, that nitrogen 15 here, this is the last step in the process. We barely have enough room. We'll react with another proton, another hydrogen atom that will give us carbon-12. And then at the same time, it will release a helium atom. And the isotope of helium will be helium-4. So take a look at what has happened. We created carbon-12 by a process we've described earlier by taking 3 atoms of helium inside of a star and fusing them together to get that atom of carbon, and we got a lot of energy out of the process as well. But then that carbon-12 was used up to burn up a lot of other hydrogen and helium. So we say that this carbon-12 is kind of a catalyst. So it helps drive the fusion reaction. So what do we get out of that carbon-12? Well, we have a way of burning up new hydrogen. Here's hydrogen. Here's some hydrogen here. Here's some more hydrogen here and there and there. And that's all new hydrogen that's being burned up as carbon goes through this cycle of reacting to give us nitrogen. And then the nitrogen gives us another kind of carbon, not the same kind. It's a little bit heavier. And then that carbon turns into yet another kind of nitrogen. That nitrogen burns to form oxygen, and then the oxygen decays, etc. And that's the so-called CNO cycle. So it's this big cycle where we take carbon-12, make a whole bunch of isotopes that all are pretty much gone by the end of this process, but we've created a lot of energy in the process here, and we've used up a lot of hydrogen in the process as well. So this is part of the process of fusion that takes place inside of sun-like stars that creates energy through, of course, Einstein's very famous equation E equals mc squared. And there are many other cycles. The CNO cycle is just one of the more well-known cycles, but there are many cycles that are like this that involve various combinations of protons, or rather hydrogen atoms and helium atoms, and then some combination of carbon and nitrogen, or carbon and oxygen, etc.